Today we're talking about de Moivre's theorem, which talks about what happens when I take a complex number like 4 cis 30 and I raise it to a power. That's what we're looking at right now. So let's start out with some review. If I had 3 cis 15 degrees squared, remember we had a formula, r cis theta 1 times t, which was the second radius, theta 2, that what we did was we took the two radii, we multiplied them, and then we took the two angles and we added them. Okay, so I can rewrite this as 3 cis 15 times 3 cis 15. In doing so, now I'm going to take both radii, 3 and 3. I'm going to multiply those, get 9. CIS, remember, is cosine plus I sine theta. And I'm going to take my two 15-degree angles, add them together, and get 30. So what we get here is we take 3, and it becomes 9, 15, and it becomes 30. That's going to come in handy as we get later on into this theorem. But for right now, we're going to pause this. We're going to look at a worksheet that we have. Hopefully some people have some textbooks in the classroom. But we're going to work through this worksheet, then we'll come back to the video and finish up this lesson. Okay, so what if I had a power other than 2? R cis theta to the third power. Okay, well, that's the same as, let me delete these as I go, if I wrote it out 3 times. And we know that I can take the first 2 and multiply them and do exactly what I did earlier, where the r times r is r squared, and theta plus theta is 2 theta. Well, now let's do the same thing. Let's take my two radii, r squared and r, and multiply them, and take my 2 theta and add them. I get r to the third cis 3 theta. So take a look for a second. Do you see a pattern? Because I have a 3 here, notice how I have 2 3's. So if I had r cis theta to the fourth, we'd have r to the fourth and cis 4 theta. And that's where de Moivre's theorem comes from. Any number n, when I have a polar coordinate raised to a power n, I multiply the radius n times, and I multiply the angle by that number. So let's take a look at this example. Now, I could take this and I could write it out 4 times. Because it's in rectangular form, I could write this as square root of 3. Oh, that's terrible. Let's undo that. I could write it as square root of 3 minus I times square root of 3 minus I. And to be honest, I'm getting tired of writing this already, so let's pretend I keep writing. Instead, what I'm going to do is I'm going to change this into polar form, and then I'm going to apply de Moivre's theorem. So I'm going to take, to find r, just like we did earlier in this unit, a squared plus b squared. And we get 3 plus 1, square root of 4 is 2. So now I'm going to take tangent of theta is equal to b over, so negative 1 over root 3. And tangent is negative 1 over root 3. If you plug that into your calculator, you're going to get in the second quadrant and the fourth quadrant. We want the fourth quadrant because this is positive. We're going to the right and down, and that's going to be at 330 degrees. So at 330 degrees, we have the angle, so we have 2 cis 330. And what I'm going to do with that is I'm going to take that and I'm going to raise it to the 4th power. 2 to the 4th. It's 2 times 2 times 2 times 2. So we get 16. And then 4 times 330. If you take that, plug it in your calculator. 4 times 330 is 1,320. But I don't want 320, so I want to find out how many times around the circle that is. So I'm going to keep subtracting 360 till I get one measurement, and that number is the same as 240 degrees. 4 times 330 is the same as 240 with a couple times around the circle. So now what I'm going to do, because the answer needs to be in rectangular form, is I'm going to go back and I'm going to change it. Okay, so I'm going to take this and I'm going to go to rectangular form. To go to rectangular form, x is r cosine theta, and y is r sine theta. So we get 16 times cosine of 240, and we get 16 times sine of 240. 16 times cosine of 240 is negative 8, because cosine of 240 is negative 1/2. Sine of 240 is root 3 over 2, so we actually get this as our answer. 16 cosine of 240 simplifies to be negative 8. 16 sine of 240 simplifies to be 8 root 3, or negative 8 root 3. Now, what we can also do is we can start to graph 4 different powers of a imaginary number on one graph. So if I take z and I graph negative I, we're going down 1. I'm going to put z to the first, because that's just negative I. When I do z squared, I'm doing negative I squared. Well, I squared is negative 1, so negative negative 1, that's positive 1. Well, positive 1 is to the right one, so that's z squared. Take z to the third. Negative 1 to the third power, or I'm sorry, negative I to the third power. I to the third power is negative I. Negative negative I makes that positive I. That's up here. Z to the fourth is negative I to the fourth. I to the fourth is 1. So with a negative sign in front, that's negative 1. Now remember, if you forget how to simplify those, simplifying I to a power, there's an I button on your calculator. If you hit alpha and then, hit second and then the decimal button, that's where I is. And this is z to the fourth. Notice how it rotates. This one started at 270, and for every time I multiplied it, it rotated 90 degrees around the circle. That's going to help us as we go on further. Okay, so we have z is 1 minus I, and we want to show the following in the Argand diagram. We want to look at z to the negative first, z to the 0, and all the way up to z to the 8th. Okay, so as we're going through this, z to the first is 1 minus I. What I want to do for a second is I want to graph that as not 1 minus I, but I want to change it to polar coordinates, because when I look at r, I get 1 squared plus 1 squared, plus negative 1 squared, which is still square root of 2, and the angle I get, tangent of negative 1 over 1, that's in the fourth quadrant, but I'm going to look at it, instead of saying 315 degrees, I'm going to look at it as negative 45. So z to the first power is square root of 2 cis negative 45. Now when I look at z to the second, we square this, 2, cis, we multiply this by 2, negative 90, and we keep going. Multiply that by square root of 2 again, and multiply 45 by 3 to get negative 135. And we keep going all the way up to z to the 8th. I'm going to skip a couple, and we're going to look at z to the 8th. Square root of 2 to the 8th power is the same as 2 to the 4th power, or 16. And we want to take negative 45 and multiply it by 8, and we get negative 360. Now, negative 360 is the same as 0. So I'm going to erase that, and I'm just going to write 0 When we go the other way, for z to the 0 power, what we're actually doing is we're taking our z to the first, and we're actually we're raising it to the 0 power. Square root of 2 to the 0 power is 1. Negative 45 times 0 is 0. And if we keep going backwards, z to the negative first, square root of 2 to the negative first power is 1 over square root of 2. When you rationalize that, you get root 2 over 2. And then we're going to take negative 45 and multiply it by negative 1, because here we multiplied it by 0, by 1, by 2, and we get 45 degrees. Okay, take a minute, try plotting these. Get a decimal approximation for square root of 2 over 2 and 2. Remember, that's the radius. That's actually not how far you're counting left or right or up and down. That's actually the distance from the center. Now, one thing to look at as you're going through this, notice that everything that has an even power has a whole number radius and has a degree that's 0, 90, 270, 180, all of those. The ones that have a degree, 45, 135, and 45, have a square root. Having a radius of square root of 2 over 2 is like going up 1/2 over 1/2. So there's z to the negative first, z to the 0. Z to the first is going over 1 and down 1. Notice we're slowly getting further and further away from the center. Then we have 2, negative 90. And if we kept going, our next one would be over here, and then over here. And we're actually making a spiral as we go around, and we'll get all the way around to 16 cis 0. So that spiral is going to keep going around all the way around this entire path going out to here. So let's take a look at this. I want to find z to the 10th, but I want to look at it two ways. I want to look at it in the way of saying square root of 2 is my radius, and my angle's 315, and I want to look at it as square root of 2 with my radius being negative 45. And then whatever we get, we're going to simplify the result. If we do it correctly, we should get the same thing for both of them. So square root of 2, cis 315. If I take square root of 2 and I raise it to the 10th power, regardless of which problem I'm doing here, I should still get the same thing. Square root of 2 to the 10th power is going to be 32. And then cis, we're taking 315 and we're multiplying it by 10, which is 3,150. Then I'm going to take square root of 2 cis negative 45, and I'm going to multiply that as z to the 10th. I still get 32 as a radius, but my angle now is negative 450, which is a little more manageable. Okay, 3,150, we need to figure out how many times that goes around the circle. So we're going to take 3,150 and divide by 360. When we do that, we get 8.75. So it goes around 8 times. So I'm going to take away 360 8 times. When I do that, I get 32 cis 270. Over here, 32 cis 450 only goes around the circle once. So it goes around the circle once. Taking away 360 from this, I get negative 90. Now negative 90 is at the same angle as 270. So this is just an exercise to keep in mind that you can do a positive angle, you could do 315, but your numbers get really big and it just takes an extra step. If you take negative 45, it's a little bit more manageable and you don't have to divide that many times or take out 360 that many times to get to the same answer.